Have you ever wondered how AI projects are built? How they're able to perform such wondrous things? Well, in this video, you will find out exactly how. We will cover the step-by-step breakdown and give you the clarity you need. Stick around because by the end of this video, you will understand how to take an AI project from concept to completion, no matter your experience level.
So let's get started by breaking down the AI workflow, how AI learns and applies its knowledge. Think of this as a step-by-step playbook that AI uses to make sense of data and provide actionable insights. Everything begins with data. It is the raw material that powers AI. Just like a chef can't cook without ingredients, AI can't function without data. The data could come from various sources. In retail, it might be customer purchase histories. In finance, it could be historical stock prices, or in HR, it could be employee performance metrics. Amazon collects millions of customer interactions daily to feed its AI-powered recommendation engine. Without this step, AI has nothing to learn. There is a famous saying in the AI world, garbage in, garbage out. What that basically means is no matter how good your model is, if your data is not good, then it's basically garbage in, garbage out. Once we have our data selected, we will now split the data into a training set and a testing set. Training is like teaching a student to solve math problems by giving them examples. AI looks at the patterns and relationships in the data to make predictions. For instance, in retail, AI learns the items customers often buy together. In IT, AI learns what network behaviors indicate potential threats. Netflix trains its AI to learn viewing habits and predicts what shows or movies you might like. After training the model, we use the second subset of data for testing the model. You see, we don't just want to create a model that works great on training data. It's like the student who has memorized the entire course material but has not really understood the concepts. We don't want AI to learn the training data, but rather see the underlying trends. Another way to look at it is, in the real world, data often has noise. For example, imagine you have a meter that is measuring temperature. Now, this temperature will always be affected by noise. It could be noise from human error, so somebody who's noting down these values might make a mistake. The noise could be from external factors, so instead of just measuring the temperature of a certain thing, it is getting affected by other things. This is also noise. We don't want the model to learn the noise. We only want the model to learn from the data. And that's a very important distinction. And that is where this testing data comes useful. Once we have trained a model, we will use the model to see how it performs on the testing data. Now, there are three scenarios that can happen after this testing phase. The first scenario is a model that is trained and works great on the training data. But when it's tested on the testing data, it performs really poor. This is like the student who has memorized the course material but not understood the concepts. This kind of an AI model is called an overfit model, and it's not a desired model. It works great on training data but does not work great on unseen data. We also call this model has not generalized. So it's not giving generalized performance. It's only giving performance good on training data. The second undesirable scenario is the model works very bad on the training data and also very bad on the testing data. This is like that student that did not study at all. Neither did they understand the course material, nor did they memorize the course material, nor did they do good on the test. This is again an undesirable model. It has not understood the trends in the training data, nor in the testing data. Such kind of a model is totally useless for us. The third scenario, which is our desirable scenario, is when a model works great on the training data and also great on the testing data. This is our ideal student. They have understood the concepts from the examples that they were taught upon, and they have applied those concepts in the test. Similarly, an AI model understood the underlying trends in the training data and used those trends to predict on the testing data. This is a good generalized model. This is the kind of model that we want to use to make predictions. Next, once our model is ready, it's working great on training data, working great on testing data. Now we can use this model to make real world predictions. For example, we used AI in retail. Now this AI model can predict the next bestseller during a holiday season. In HR, an AI model can identify which employee might benefit from a specific kind of training. In finance, an AI model can flag unusual transactions as potential fraud. fraud. A real-world example is of PayPal. PayPal uses an AI system that predicts fraudulent transactions based on patterns in user behavior. It monitors how did the user behave in making the transaction, which location, what are the activities. Based on several different factors, the AI is able to identify a valid transaction from a fraudulent one. Let's take a hypothetical use case and walk through the workflow. Let's imagine that a bank wants to use AI to build a loan application system. First thing you would need to do is gather data. This data would include all the historical loan applications. It will also include applicants' demographics, their age, income, credit score, loan details, what was the amount of loan requested, purpose, payment terms, and finally, what was the outcome of the loan. Was it approved, rejected, was it paid back on time, or was it defaulted? With all of this historical data, we are now ready to train an AI model. As I mentioned before, we will take a subset of this data and train an AI model. This AI model will now learn patterns and relationships such as how credit score impacts the loan repayment likelihood, which combinations of factors are most associated with successful loan payments. Once an AI model looks at all of this, it identifies a trend between successful loan payments and defaulters, applications that were accepted and applications that were rejected. Once we find an AI model that is working good on the training data, we use the testing data to now test this model to see if it has understood the underlying trends. Later, we will also talk about specific metrics that we will use to evaluate AI models' performance. For instance, accuracy is a metric. We can measure what was the accuracy of the model on the training data, what was the accuracy of the model on the testing data. If both of these are good, then our model is good to go. But hold on a minute, our AI workflow is not complete. The most important part of our AI workflow is human oversight. Just like in that example I mentioned earlier, Microsoft deployed the model Tay on Twitter and it got corrupted so quickly. And this is where human oversight is extremely important. You see, AI is powerful, but it's not perfect. It relies on humans for defining clear goals, providing quality data, and ensuring that its predictions align with ethical and strategic objectives. To sum up, AI workflow follows a structured process. We first collect data and make sure that it is useful for our use case. We use a subset of the data for training a model, another subset for testing the model, and then finally, we can use that model for making predictions, all the while having human oversight over this entire process. This workflow is the foundation of all AI systems, from chatbots to recommendation engines to fraud detection tools.
Want to see how you can apply this to your career? Then join us on our 14-day journey into AI mastery, where we dive deeper into concepts like AI workflow, model building, and real-world applications. Whether you're in IT, finance, healthcare, or any other industry, this course is designed to help you integrate AI into your career. Click the link below in the description to learn more and secure your spot. We can't wait to see you in the course.